Hi AP Psych friends, we are looking at Unit 2 Research Methods, and this is Part 3B on experimental research. So to review, you've watched a video on descriptive methods of research, you've watched a video on correlational methods of research, and now we're going to talk about the experiment. So remember, the purpose of an experiment would be to determine whether or not we have a cause-effect relationship between two variables. And before we begin actually talking about the components of an experiment, let's look at something that is known as an ex post facto or a quasi-experiment. Sometimes this is called a non-experimental method. And what's happening in situations like this is that we're in psychology attempting to test the effects of some variable that we would label as a classification variable, like gender. Maybe we're trying to experiment, like, does gender affect X behavior? Well, unfortunately, in a situation like that, I, as the researcher, can't manipulate the independent variable because, well, people have already been assigned to a group. I can't really change a person's gender, at least ethically, that is. And so I'm not saying that that type of data and research isn't valuable, but we just have to be careful in that they aren't true experiments. Okay, so the experimental method has a lot of new verbiage, so let's get going. When we do an experiment, we have to determine our independent variable and our dependent variable. Our independent variable is just going to be what the researcher changes or manipulates. I like to think of that as the cause, and then the dependent variable is going to change as a result of the independent variable, at least hopefully, if our hypothesis is true. And think of dependent variable as your effect. So will X lead to Y, or will X make Y happen, right? Will independent variable make dependent variable happen? When conducting an experiment, you always have to be mindful of what are called confounding variables, which in general is just going to be any factor that could affect the dependent variable, either along with the independent variable or instead of the independent variable. And so let's do a couple examples of confounding variables. A random variable is a confounding variable that's uncontrolled or it is uncontrollable. So like you're researching on people, and so everybody has their own life experiences that they bring to the table when they participate in research. You know, the time of year that it is. There are just some types of confounding variables that could potentially affect our dependent variable that we just don't really have any control over. Demand characteristics is just used to explain situations where participants form some sort of perception or interpretation of the experiment's purpose, and then unconsciously change their behavior accordingly. And so either they might try too hard, or they might try to behave in a way that they think conforms with the experiment's purpose. Okay, and so you have to be mindful of, humans just being naturally curious and wanting to try to figure out, I wonder what they're experimenting for, like what are they trying to get out of this. And then the last one mentioned there is the Hawthorne effect, and that's actually based on a Hawthorne factory study that was done many moons ago, where they were researching whether or not the amount of light increased or decreased factory workers' productivity levels. And so, they have all this research, they find, the correlation. Now we're going to conduct the experiment. And what they found out actually was that it wasn't the amount of light that was affecting worker productivity. It was actually the fact that the workers were being studied. And so being watched was what increased productivity, and not being watched was decreasing it. And so we use Hawthorne effect to just describe situations in experimental research where people might change an aspect of their behavior that's being measured simply in response to being studied. And so our goal as researchers would be, can we eliminate as many of those confounding variables as possible and decrease the effect that they could have on the outcome of our research. When we are conducting an experiment, we have to decide who is going to be a part of our experiment. And so let's talk about participants in an experiment. With your participants, you're going to have a division of them into either your experimental group or your control group. Your experimental group is the one that receives the treatment, and your control group is the one that does not receive the treatment. And you may be asking yourself, why in the world do you have people in your experiment that are not being experimented on? Well, if you think of it in math terms, right, you're trying to isolate the variable. And so we use our control group as a comparison to ensure, right, that the effect of the independent variable is really a result of that and not one of those confounding variables that we talked about in the previous bullet. And so how do we get a control group to still play along with an experiment? There's a couple of things. First, members of a control group usually receive a placebo. And again, this is not your official book definition, but think of placebos as fake treatment. Okay, and so we want the control group to have that in order to ensure that the change that we see is a result of the independent variable and not just the belief in the independent variable, right? So I guess belief in the independent variable is a confounding variable in and of itself. And so we want to make sure that the dependent variable is happening as a direct result of the independent variable and not just somebody's belief that they are, taking an awesome new drug that is totally helping them. Right? And so, like in a situation where you were experimenting with a new medication, your experimental group's getting the actual dosage, your control group is getting a fake pill that they do not necessarily know is fake, and then we can just, record all findings and determine later whether or not it was a result of the independent variable. Good experimental research is done using the double-blind study method, which just means that neither participants nor researchers know who is in the experimental group and who is in the control group until after the experiment has been conducted. Okay, and so a third party would come in, divide up participants into one of the two groups, administer the independent variable or the placebo, right, and would keep the master list of who's who a secret until after it was done. Obviously, the purpose of that is to eliminate any experimenter bias you may have. Especially when it comes to a lot of this pharmaceutical research. I mean, there's a lot of money to be made in the discovery of an effective drug, in the treatment of some sort of disease or disorder. And so you don't want your own bias or your own desire to be right to get in the way of good research and good experimentation methods. All right. We are almost done here. The last two things to mention concerning the experimental methods are random assignment and counterbalancing. Random assignment is similar to random sampling in the descriptive methods, right? And so when we were trying to take a portion of our target population in conducting a survey using descriptive methods, we wanted to make sure that members of the population had an equal chance of being part of the research, and so we called that random sampling. It's the same thing in an experiment. Random assignment is just saying that participants have an equal chance of being placed in either the experimental group or the control group. Okay, Why is that important? What's the purpose of random assignment? We're hoping that if everyone has an equal chance of being in one of the two groups, that I guess it's presumed to distribute the impacts of those random variables, right, by minimizing the chance that they may distort the results as a result of people being randomly assigned to experimental or control group. Counterbalancing is just when conducting the research itself, it's being mindful of the arrangement of the procedures or the arrangement of the treatment factors. And so you want to try to neutralize things like practice effects or fatigue effects. And so like if you were having, like especially if you're doing some sort of experiment on like does calisthenics or exercise, lead to this change, doing things in a specific order every time you conducted the research may actually distort your results. And so like if there were two tasks you were wanting people to do, perhaps you would divide the participants into two groups and have group A do task number 1 followed by task number 2, and then have group B do task number 2 followed by task number 1. And again, in an attempt just to eliminate any sort of fatigue or practice effects that could get in the way of good research. Okay, so we can gather our data using those descriptive methods we talked about: surveys, observations, case studies. We take our data, we look for patterns and relationships between variables using our correlational methods of research. And then finally, of the things that have correlation or of the things that have relationships, can we determine cause and effect between some of the variables that we have discovered in our research? And to do that, we'd have to conduct an experiment. So I hope that this has helped clarify some of the issues concerning research methods in psychology. Feel free to bring any and all questions with you to class. Thanks.